Morning.
Good morning.
Barely.
No blood.
No, I have to do the you get 99 point something percent. And so then I watched for a long day. I had to nights do like 5 minute reaction next to it. It was amazing. 1%.
Yes, and then
Got stuff for you.
an ophthalmologist, NPR yesterday, and it's like, even that 1% can cause corneal scarring. It's like, he said he had to get surgery on the patient's eyes, and he said that this part was the crest. They had your eyes at a 1%.
This is, I had to recopy that first page. And then I had to recopy a couple of pages in that section.
I did. Writing is what the job.
So Brittany, here's what we forgot.
So then you learned around.
I might have, there's a reason
And then it was 11 o'clock, and I was like, no, I'm going to
At least at 6 this morning, I can do this one, guys.
No, I can do this.
You're one of those people. When are you gonna get yours?
Oh, whenever she You have your book. Well, this one has this book, so
I'll be honest with you, I started downloading
who's the last person?
and started rendering music.
For me?
I put
Okay, I would do. Sure. I do not like being. I feel
Oh, you could do it.
I don't know why. If we have problems on the homework, can we have you help us? Yep. Okay. Good. I just wanted to make sure.
I've got problems with the homework.
I feel like it's works effectively.
Yeah. Oh, this one.
It's so not in a good mood.
For my accommodations thing, I did.
I made the homework so much faster.
Do I need to like fax it to him? There's a friend back.
I actually, I read
I don't
the
know.
whole chapter. This was like, I was like,
I mean, you
there's
can
no-
give it to me and I'll send it to him.
That'll be fine. I was taking no chances.
I'll just email it in my office.
Yes. So that was fun.
I was
I took notes all the way.
doing the rest of it.
I kind of guessed.
I got a film check and I got really excited.
Or made something up that sounded right. Very
I'm like, you know, this is an investment for you. Yeah. But then I did all of these. I know that one was kind of sketchy. And I didn't know those.
All this homework. It's like they say we need to have an answer.
And the answer, yeah.
So I said, I realized, look at my graphs. There's 10. It's ready. Look at this one. My computer broke.
Boy, that's a grinding sound like that.
How was the eclipse?
It was cool, but you know what? I gotta say, I wish I had gone ahead and driven to the gallery.
You didn't get that art.
Whatever it was. It's definitely not very awesome, but it's still, even not 28% of stuff. Amazing, right?
Okay, Dale, we're having some serious audio issues.
Here, is it better now?
That helped it.
Okay, talk some more.
That help now?
Tell me about the clips again.
We had a fan running because it's hot in this room. So, we had a fan running to try to cool off with it. The eclipse, it was fun. We sit out in the parking lot out here, a group of us, and just kind of, there were some people, some random people who pulled in up the street, I guess. You know, one guy was from Asheville. I'm not sure why he was down here. In the parking lot with us, and had our own little mini party out there. It was a little disappointing because it didn't get. I thought it would get darker. 99%.
You only had to drive like 10 minutes to get to total, right?
Well, maybe
30.
Maybe 30.
Oh, 30?
Yeah.
Because it doesn't tell you why it's false.
You weren't even here.
What was it like there? If you're an eclipse there, you get like, I saw the map go get about 95%.
The audio is still messing up. I'm not sure what's going on.
I quit.
Can you describe how it's messing up?
It's just breaking up in the middle of his sentences.
Maybe I need to back up. How about I back up? Can you hear me better now? Can you see me now?
I can. Yeah.
Hear me better now? Well, that's
Yeah.
interesting because there's two microphones right here.
Let me try something. Amanda, we're gonna go on in just a second. The audio.
Okay. Okay.
I still can't understand.
Miss Clingers.
Hold on one second.
Okay, how about now? Do we sound any better?
All right.
Talk a little bit.
Hello. Hello. Can you hear us better now?
Yeah, that sounds good.
Now theirs is I can barely hear her.
Yeah, we turned it up.
We just heard her.
Say something. And pull out.
Say the red dot.
There may be some homework questions from last night.
No. There can't be any questions. We've got this covered already, man. I hope, honestly, I was hoping that would garner some questions. That was partially the intent. Go over and let you dig in and see what you figure out. So, good. We'll cover those questions. Did y'all get out and look at the eclipse at all? I mean, did you all have glasses and stuff?
We did. We did look at the eclipse. Me and my children. It did.
Dark.
Yes.
It did get a little dark. It did.
It got really easy looking.
Yeah, it got really weird, dusky
The lighting
looking.
was weird, but it wasn't.
Yeah.
What happened? I mean, we were still looking at it during that time, but didn't realize it.
We might have.
It was very dusk. It was dusk looking.
It wasn't.
Dusk.
It wasn't like sunrise or sunset where the sun is on one side of the horizon. It was like
In the winter,
it was just in the middle of the sky. It was just dark.
Yeah, it was.
No, I got really lightheaded from looking through the glasses. So like all last night,
I was like that too.
my vision was blurry, and whenever I saw light,
I was like that too.
Did you drive here?
I bet I'm assuming are the silver ones on the left?
Yeah, the green line. Before. Yeah.
It was fun. It was about 5 hours
You
afterwards.
put it all next to that.
Is there any details?
I just turn it off.
So,
So Dale, before you get confused, Sammy decided to move to the back. So in your seating chart, she went from the seat way up front to the seat closer to the back.
Wait, Sammy.
And Elise, I guess, will move on the other side of Brittany.
Okay, so where it was Elise, now Sammy.
Sammy,
Yeah.
Sammy, wave your hand.
Okay, and then
Sammy's up here.
is Elise will be, where's Ray? Is Ray still with us?
He hasn't gotten here yet. He'll be coming in a minute.
I put them on the big screen here so it's easier to see.
Okay, so who's next to Sammy?
Oh, there he is. That's Brittany.
So where did Elise go?
She is now next to Brittany.
Send the email.
And we'll just move Rezo over one more, I guess.
I move Ray's up front.
Move Rezo up front.
So next,
Yeah, we're fine with that. Yeah, we'll take it.
Cindy's still in the back corner.
That's Sydney.
Josh, Glenn.
Is that lady?
Yeah, who's the lady sitting there next to Justin? Josh.
Is that
That's
Chloe?
Chloe. She's the one that went to South Carolina to see the eclipse.
Oh, where in South Carolina did you go, Chloe?
Chloe.
Chloe,
Huh?
hey, where in South Carolina did you go?
Went to Joanna, South Carolina. It was weird, but
Was it eventful?
yeah, it was really cool.
Rezo, they moved you up front.
Okay.
I was kidding. Hey, Ray. So we have, Kyle is not in yet, is that correct?
Right.
Mr. Carson, Bree, and Ellen.
Yeah, we felt.
We saw the sun, and it looked completely normal.
I sat in my room and it looked like.
That was so disappointing.
Then it was probably a
Yeah.
cloud because it didn't get that far.
I expected some shadow, I had child level darkness.
expecting him to do that.
I didn't get it.
I knew they were gonna be underwhelmed. I knew you were gonna be underwhelmed.
I wasn't underwhelmed. I was just.
You were underwhelmed.
I wasn't expecting more as in sunlight. I was just expecting it to get darker.
I can't hear you. What? Okay.
Chloe, did you get to see what they call the Ring of Diamonds during totality?
I don't think so. It was like completely dark and there was like a ring around the moon, but I don't know if you saw that or not. There was a cloud that came in. Like,
Well, I have not seen it, but I've heard or read that during the totality that the sun beams will come through the mountains on the moon before it's like a ring of diamonds around the. Or was it totality? Okay, so one thing I neglected to mention yesterday when we were talking about the
Oh, yes.
syllabus, in terms of grades, I don't know, anybody look at the syllabus on Google and all that we talked about? So in the 80% grade portion, which is the majority of the grade, 20% is for the final exam, 80% includes tests, quizzes, homework, etc. But one other thing I did not mention is attendance. And so that's part of your 80% grade is attendance, and that's written in there at 3 points a day. 3 points a day. And well, that's there to emphasize that I think being in class is important, especially I think mathematics, upper level mathematics type functions. It's part of your grade, and therefore there is actually a penalty. So if you are here, all period is 3 points. If you come in late, you lose a point. If you leave early, you lose a point. If you don't show up at all, you lose all 3 points. And at 4 days a week, 16 weeks, that's 192 points possible for a whole semester. But I know that there will be occasions, oh, my alarm didn't go off. And I tell them before I got behind the school bus, and I just couldn't. So I will at the end discount from the 190. Hello.
Hey Dale. It sounds like you're underwater now. Is the sound guy still there?
Yeah,
That's what it sounds like.
Yeah, honestly.
No exaggeration.
Get the man on
I'll let one watch.
On this side.
Get back up again.
because the
Can
other
you hear me
speakers-
better now? Can you hear me better now? Hello?
So talk about the 1 point, 2 point, 3 points again.
1 point, 2 point, 3 point. So it's 3 points for each day of attendance. A deduction of 1 point for being late. A deduction of 1 point for being leaving early. And a deduction of all 3 points if you're not here. Of the 192 points possible for the semester, that's 64 days of attendance. I will, at the end, reduce that by, what's it going to be? How about 8? We'll do 8 points. 8 points. That allows you to be late once or twice accidentally, or maybe even have to miss a day, whatever, and still not be penalized. So you can earn more points than are required for that part of your grade, if that makes sense. So it's like built-in extra credit just for being here. That makes sense, everyone?
Sure.
Yeah.
Raise your hand if you have no idea what I just said. Raise your hand if you went home and at least tried to read through section 0.1 of the textbook. Raise your other hand if you actually put some effort at trying to do some homework in section 0.1. Raise both hands if you did both. Okay, good, yeah. I have to stand back here.
I think that
It may be because these microphones are working better than the ceiling microphone.
Well, there are microphones everywhere, these little black dots, all right. So they should work anywhere, but you could hit that line where there's some weird sound.
Did he sound better earlier?
That's the guy's asking a question.
Okay, so now's our opportunity to say, do we have questions? And I've gathered some data that indicates we might have some questions. That's a good thing. So, we'll start with number 1, problem 1. I'd like to go over that for a few minutes, and then we'll actually get into questions. So, problem 1, you have true-false question. And you're supposed to answer true or false, and you're supposed to explain it. From page 14, I'm going to ask here at ICC, please make sure you speak up so they can hear you as well when it's your turn. And Davidson County also will ask them to make sure they can hear.
Is that the isothermal?
So, problem 1A. I'll just go ahead and kind of demonstrate, I guess, how we want to do this. So 1A, true or false? Functions are the same as equations. Most have only ever studied functions as equations, but according to the definition, that's false. What does the definition say? The definition says it's a mapping between two sets, right? So I would reference the definition and say, no, false, it's just a mapping between two sets. Here's the example, a counterexample that's not an equation. How about, I come up with an idea, example that's a function that's not an equation. about the mapping of for each person's social security number to your last name. That's not really an equation I can write out with all the X's and stuff, but instead of social security numbers, each social security number has only one output, your last name. With that function that I just created, so this is more than you have to do. I'm just being a teacher. So with that function I just created, would it be a function if you went in reverse, like last name mapped to social security?
There's more than one last name.
Did y'all hear this back there? And Davidson? No, say it again.
There's more than one last name number. There's more than one number. You know.
Y'all hear it now?
Drowning.
I think you're gonna have to say it. I can't hear anything that Doug said.
No, because my last name is Hubbard, and there are more Hubbards than just me, so Hubbard gets mapped to different social security numbers. So that's how a functional brain definition.
Cool.
All right, does that sound? Okay. Now, 1B, who wants to volunteer? If not, I'll volunteer. We'll do an Army style here. Military volunteer, you know what that is?
Does it include a bar of soap?
It means that, let's see, Razor just volunteered.
What?
You volunteered.
Okay, sure. I put false.
Military, that's military style volunteer. You just volunteer.
I put false.
Thanks for volunteering.
I put false for 1B. F,
Read it to us,
false.
please. You can read it to us, please.
Okay, true or false, the domain of every function is a subset of all real numbers. And I put false.
Okay, why? I'll agree with you.
I kind of just guessed on that one, to be completely honest, but
Well, I mean, that's getting Vegas, but that's not what we're doing here. So, anybody have a suggestion? You can phone a friend if you want. Anybody want to help out raise a why? I agree, that's false.
I got two choices.
Yeah, you have a 50-50 shot, you know, that's heck, yes.
Phone a friend. Does anyone have an idea?
Oh, I see. You're nice. Help them out. Help out, raise.
What was the question?
I don't know what you said. What did you say?
It only works if the f of x is defined.
It only works if the f of x is defined. Whatever that means. I don't know. You guys are telling me this.
Well, how about, can you, okay, since you agreed that it's false, I agree. So that means you should be able to provide for me a counterexample that is an example that is a function but doesn't satisfy the criteria stated in the sentence. Criteria says that it has to have a domain that's a subset of real numbers. That's not what it says.
1 over x.
Is that what it says?
What does it mean a subset of all real numbers?
I just heard about it.
You know, it is. Go
It
ahead.
doesn't have.
Oh, you had it. Go ahead.
Huh? Well,
Hey, you
like a
start this.
subset is like a little chunk out of all the real numbers. So if it goes on like infinitely, or if it's not a number, it won't work.
Yeah, that's it. I guess we'll take it.
So yes, if it's not a real number
Take it.
as the domain, then that would satisfy showing it's false. Can you come up with an example where the domain set is not a subset of the real numbers?
Oh my god.
Slices of them
How about
Isn't it dark?
each person have a singular height? Like you can measure them, they have one height, they have like all points.
Yeah, they have one height.
Right, so you could map a person to their height, and that would be a function, would it not? So the people represent the domain, that's the starting part. Is that a real number? Is Maddie a real number? So no, those are not real numbers. There's an example that's a function. The domain is not such a real number. We need another volunteer. Good job there, Basil, for stepping up and volunteering like that. Anybody else want to volunteer, or do we need that? We're on one seat now. But Joe, we'll let Joe here at IC is going to volunteer. Speak up, please.
It's false.
Said it's false. Anybody else agree with that?
I agree.
Yeah, I agree. Okay, I'm going to agree too. I think it's false. Did you read it for us, though?
That for each x has output f of x equals 1 is a 1-to-1 function.
You said that's false. Why is that false?
I remember the exact definition of a 1-to-1 function, but that's not it.
That's correct. That's not it. How is it? What is a 1-to-1 function? What's it mean to 1-to-1?
Every x is a y.
That's
Which
right.
are different.
Say that again? Yeah, sort of. Yeah. Maddie, what did you? Sorry. What?
Because you need to wait for the class.
Okay. There's a statement in there that says 1-to-1 if you have f of a equals f of b, and that implies, oh no,
I can see him, Miss Klinger. I can see him.
a equals b. This is kind of the definition of 1.
Okay. Okay.
So anytime that the output is the same, then the input had to be the same, is what that's saying. Anytime the output is the same on the left, then the input has to be the same. So why is this one not 1-to-1? You give me a specific example of why this is not 1-to-1.
Oh, well, actually, I don't know the answer to this one.
Well, first of all, it's a horizontal line. F of x equals 1 is a horizontal line at 1. So does it pass the horizontal line test? Clearly no. Could you do it with this definition here as well?
Dale.
Yeah.
I don't see it, but I assume it's. Come on, get close.
Oh, this function, you're given that f of x equals 1 for all x, right? That's what it says.
Mm-hmm.
So then what is f of 3? What is f of negative 17 equal to?
1. It's not cool.
Does that mean that 3 is equal to negative 17?
No.
No.
No. So then therefore it's not 1-to-1.
Dang.
See this? Good. Making progress. Any questions so far? I bend over and talk so you can't hear. How about number D? Volunteer? Not be shy here, folks. We'll go back to DCC. Who's up? How about Brittany? You're our next contestant.
And the price is right.
I said it was true.
Please.
It's true.
Read it.
Out loud.
every global maximum is a function of a function is also a local maximum.
Dang, that's true.
True.
It's true. Absolutely. The world is one.
Good, I agree. Can you elaborate why that's true?
It's because every global max is a local max, but not every local max is a global max. So there's always going to be a local max or min, but only one of them can be the global.
So I agree that what you just said is basically a restatement of what this says, that every global max is also a local max, not every local max is a global max. In the definitions, how is that, what in the definitions and your theorems shows that that's true?
The global is the highest.
Like on page, if you turn to page 6, see a whole table of definitions. Look, if you focus your attention on the local max definition and the global max definition, be observed. What's all that algebraic gibberish say to you?
Hey, honest. I don't know.
Well, let's read it, okay? So f has a local maximum at x equals c means, or by definition, f of c is greater than or equal to f of x for all x near x equals c. Okay. Am I making sense to anyone? Can you describe it? So f of c is greater than or equal to, what is that? What's greater than or equal?
They're the same.
It's greater than or the same. That means it's bigger than or the same. And it says for all x near c. So in a nearby region at x equals c, got x on the x-axis, so x value. Near that x value, all of the outputs are bigger than, smaller than, 1 at c. What does it say for global max? It says the same thing almost. It says f of c is greater than f of x. This says for all x in the domain. So if it's the highest, largest for all x, it's certainly the highest or largest in x region near c. If it's the highest for all of them, then it's got to be the highest, just a small region. Okay, there you go. So yes, you're right. That all global maximums, also local, not all local. Okay? Where are we? E? Randy, you want to take the lead? Read it out loud enough, sir.
Every local minimum of a function is also a global.
False Y. We just kind of went through that, didn't we? Now, they didn't have minimums in that table. Could you define minimums? Let's take a look through that one very well. In that table we just read. Oh, define. Did you define global minimum? Someone? F of C is less than or equal to F of X. That's correct. What? one did I say? Local and global. Two local. It's two local. So local min. That's what we're defining. All x here, x equals c. Good. That's local min. So this point is always smaller than or equal to all of the other y values near a certain location. What about the global minimum? I mean, this isn't in the book, but it's implied. You should be able to quickly make that transformation in your mind. So what would be the global? Someone else? Oh. Let's see. Emily, can you help us out on the global minimum?
So f of c, it would still be less than or equal to f of x. But then
Continue.
for all x in the domain.
Yes. I heard was that an O, like a inspiration, like, oh, I just did it, or that's good.
I get it. Yeah.
Good. Amen. Okay. Let's see, that was E equals. Yeah. Now we're at F. Let's see. Who hasn't participated yet? How about Dylan? Dylan?
Yeah. The graph of a function can never cross one of its asymptotes. And I put that as false.
Very good. Can you give me an example? Point to one in the book, man.
The tan functions, they cross the asymptotes. Like y equals tan. Is that not?
I don't think that's good because it doesn't cross.
It does? Okay. But I mean, I've seen graphs that you don't.
But they never touch.
Yeah, they never
I mean,
touch.
You can cross
They
the
don't
asymptote.
touch it, but they go on the other
They go
side.
Isn't there a hole? There's a hole or something?
A tangent function, I think, looks something like this. But I think what you're saying is, well, then it goes on past there's more to it past each asymptote. I agree with that, but that's not what they're saying. They're saying cross it. They mean literally intersect the asymptote. So that possible. There's examples in the book.
There's a horizontal one.
They referenced it.
I don't know what it was though.
Page 7, direct you to page 7 at the bottom, and talk about asymptotes, and mentioned that what you kind of learned before, you never touch it or whatever, that's a little bit inaccurate. Get infinitely close to a particular value as x or y values get infinitely large. And so in this picture, the y values are getting very close to the horizontal asymptote of y equals 1 as x values get infinitely large to the left and the right. And the x values are getting very close to either -2 or +2 as the y values get infinitely large in the positive or negative direction. But you'll notice the graph actually crosses or intersects horizontal asymptote of y actually crosses. And you can have a function that crosses the horizontal asymptote multiple times. Now, I will agree that you would never cross a vertical asymptote. Explain why you would never cross vertical asymptote. And cross. Why can you not cross vertical? Y'all remember that from pre-calculus? Take, for example, it's a tangent. So this is y equals tangent x. Why is it that you can't cross this asymptote on these tangent curves? Say it again, look. Because the function's undefined at that point, at x value. That is correct. So when the function's undefined like that,
Good.
good. Now where are we?
I think I get it. Is it because the independent variables on the bottom or something?
Well, yes. Now that was an example of a trig function, but yes, you could have a polynomial or rational function. This could be a rational function, and in a rational function, you would have a undefined x value if the denominator becomes 0. So that x value creates undefined. Well, in fact, tangent is undefined at where is tangent undefined? That comes up like that.
There's like the zones, right? There's
What is
zone-
tangent?
sine over cosine.
It's sine over cosine, so when it's undefined.
Z is pi over 2.
Oh my god.
I don't know.
It's one of those. So which one was it? You say pi over 2?
Is it?
Yeah.
Oh, sweet.
Cosine of pi over 2 is 0.
Oh, look, that's me.
It's all of the odd pi over 2. So how about G?
G. Who's the real G?
B?
The average rate of change can be thought of as slope.
Okay. Change the average rate. Plus the bookkeeper said it right in the reading. The average rate changes the slope of the line that connects two points. Actually, specify that. And by the way, that average rate of change is written too. You ought to see it as what you've learned since 7th grade. So how did you calculate slope in 7th grade?
Rise over run.
Oh, yeah.
Now, rise over run. Good, I'll go with that. Did you learn some formula involving like x's and y's?
The change in my.
The delta thingy.
Ah,
Delta.
good. Perfect. Delta y over delta x. Good. There you go. Which was something like y2 minus y1 over x2 minus x.
That's it.
So, but since y is a function of x, and this is just f of x2, that's a function of x, so that's just f of x1.
It's okay.
So this is what they specified as average rate of change.
They made us do A and B though in the book.
Well, we all knew was on go to they didn't find the box. That's fine. A's, B's, X1s, X2s, it's all the same. So yeah. X2 equal B and X1 equal A and how that. H. Final one. Up here. Or final volunteer then. Mason, you want to take this one?
Okay, so H, true or false? A function can have different average rates of change on different intervals, and I put true. It can have different intervals can have different rates of change, and I guess it really just depends on the restrictions you have on the domain and range of like what values can be, like the example given in the book. If I can find that real quick.
You could just use an exponential function, right? Increases faster as it.
Oh yeah, an exponential function is a good example of that, as Rezo said, because it continuously increases the rate of change as you progress further along the graph.
Excellent. Just tag team on that there too. Now we're finished number one, so we'll just try to. We're not going to do a whole bunch of exercises. Maybe we can cover some. What other questions do y'all have? That you ran into and you say, "Oh, I just don't get this."
What did he say?
Which other exercises in section 0.1 that you attempted to struggle with and attempted, don't ask a question, but if you attempted and you got stuck,
Come on, Sammy, ask your question.
Sammy.
let's write some of these down. That way we'll keep track. So, Joe, which one did you say? What other ones do you have?
Actually, you answered mine earlier. You answered mine earlier with the, yeah, the social security name, and then.
Okay, so going through number one may have helped answer some of the questions you had previously. That's good. That's excellent. That's good. Transference of knowledge. That's a skill you can have. That's good. Other questions? I do a lot of questions. I'm not getting any. Okay, that's a good one.
What about number 2?
Yeah, I couldn't even get anywhere with
Number 2. Describe examples of the things described in the following. Try to find examples that are different than any intermediate function that is defined with a formula. Can I get A? Defined to the formula. That was in the book. Something not in the book. Okay, there's a function defined as a formula that's not in the book. You all agree?
Thank you.
A function that is not defined with a formula.
Which we were talking about earlier with the social security card.
Yeah, something like social security number and last name. Like we did earlier. That would be a function that you can't write as a algebraic formula. Formula that does not define a function. Anybody come up with anything there? Okay, we'll start thinking graphically. What would it take graphically to have a picture that's not functional?
That's a function, right? No, it's not a function because it doesn't pass the. Could you do a circle?
But something that was like f of x equals a number.
Yes, you could.
Number is not.
It's a
Fine.
circle.
That's right.
That's not a function. Why is it not a function?
Because it doesn't pass the vertical line
test.
And what does it mean when it doesn't pass the vertical line test? What does that tell you about the definition of a function?
Is it not one?
Got it.
Yeah, it's not just because I memorized this thing called vertical line test. It's because the definition says for each x there's only one y, and the vertical line test shows me an x value. Here is an x value, and it has a y and a different y. So it doesn't satisfy the definition. So all you have to do is come up with a formula, and a circle is a perfectly good example. So what kind of an equation and formula could you write for something like this?
You have to use the h and the k.
Yeah. R
So you
squared.
need an h. But yes, let's remember what was the general equation for a formula, something like this.
I can't see it.
Probably.
You gotta zoom in. Yeah,
Zoom
keep on
in.
going.
X minus h squared plus y minus k. Y'all remember all that now?
I can take it. Yeah. I'll take it.
What would be an equation for this one?
Well, its center seems to be at the origin, so there's no h or k.
So you can just leave it like
So it's just x.
Pick up a number for our formula.
square equals 1.
Uh huh.
Equals 1.
Is it 1?
Okay, whatever, yes, you could have put 17 if you wanted, that's fine.
I didn't see no numbers, so I was just
stick
assuming.
easier to put y equals 2.
Okay. Any other questions? It's difficult. This type of thinking is important in my opinion. It's difficult to create examples rather than to analyze. So the creation side of things is important. But that's good. Other questions? Okay.
I have a question.
Okay.
On number 10, there are 3 examples, and you're supposed to find out if they're functions or not. And I was wondering about letter H, the last one, with the 3 that doesn't have a value.
Okay. That's a good question. First of all, what did you say about, let's just review, what did you say about F? Since you asked the question, what did you say about F?
F? I said F is a function because each x only has one y value.
Excellent answer. Okay, what about G?
G? No, because 2 has 2 y values.
Okay, what about H?
I put yes, but I wasn't sure because that 3 has nothing on it.
Okay, go back to F. Say again what you said when you answered for F. So yes, because.
Okay. Is it a no? Is it a no because 3 has nothing on it?
Correct. And what did you say for F? Say again exactly what you said.
It's a function because every x value has one y value.
That's every being the key word.
Okay.
Good. Other questions? Try. I think once you get through the first batch of exercises, when you go to the next page, it's more your traditional. Instead of having to create stuff, it's just here's the problem you analyze it. It's more. Number 11 and 12, I heard.
11 and 12.
Cool. F mapping 2, 4, 6, 8, 10 onto 1, 2, 3, 4. That is a function. Express this function 3 ways. This has a table, has a diagram. So I have to make a function and express it 3 ways. Then I have to identify is your function 1 to 1 and is it, and what is its range? There's a lot of choices. I'd hate to do the permutation on that. If I have an answer, a lot of choices on answer. So what did they tell us the sets were 2, 4, 6, 8, 10? And of course, this is called your domain. This is called the codomain. Range is whatever subset of the codomain that you actually use.
Joe, can you zoom out just a tad?
Another
Better?
A little more.
Your
So we
tab.
can see.
Good now?
Yeah, that's good.
Where was it off the screen? Was it too high on the screen to see? Is that what it was?
Yeah.
Yeah.
Good now? So I think found the problem. And the question is write a function and do it in 3 different ways. It was a list, a table, and a diagram. Okay, so I'm going to do a list because that's the easiest thing for me. Is that a function?
I'm confused. Yes, it's a function.
Yes, it satisfies the definition of function. And that's in a table.
I don't understand why those f of x values though. Like why you repeated 1 and 2. I expected it to go down the list of codomain numbers.
Okay. This is my function.
What does that say? I can't even read it.
Thanks for your name.
Oh my God.
What's that say?
E-I-Z-O.
Ezo?
Raizo.
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 Oh, it's like gas, because that's
Raizo.
Gaddis.
What did you want in your function?
What is
All
it?
of the numbers.
What did you say? He wants to know the numbers I put down? I put 1,
What
2,
number?
3, and then I didn't know what to put for 10.
You could repeat 4.
Okay, I'll put 4 again, just for kicks.
So does it not matter which numbers you use as long as it's in 1, 2, 3, or 4?
Correct. As long as it's a function, meaning it has to have one y for each x, every x has to have a y, and the y values can only come from the codomain.
So it doesn't matter which one of the numbers you use as long as it's.
What?
So
Man.
what is the range for the Gaddis function?
It's 1 to 2. Right?
Range for the, yes. What's the range for the Raizo function?
1 to 4. Bombing. For the Raizo.
I don't even care, man. They're all the same way. Wait, I thought.
Now, how do you put that in list and then diagram form?
List. Looks like a list to me. For real. It looks like a list to me.
It's like a table to me.
Well, I'm talking about the thing on the bottom. It looks like a list of numbers to me. But then again, that's the range.
that's the range, and that is a list. That is correct. But we want to find the function in a list form. So how do we do that? So it has to be similar to this. You're right. Good observation. But we want to do the function that way. So how do we do that?
You want me to do a list of coordinates? Is that what you want?
Yes.
Okay.
Like 1,
Just talk.
2, 1, and so on.
Alright. I did that. Wow, I got it right.
So that's in list form. Oh, I didn't finish it. But that's the idea. And then you have to put it in diagram form. So,
So like a graph.
well, what do you mean by graph? Yes, it's like number 10. So number 10 is a diagram. A graph would be plotting on the XY coordinate system, plotting ordered pairs. Function 1 to 1. So is yours function 1 to 1?
Wait, what did you say? Is my function 1 to 1? No.
Be good.
It's not a 1 to 1 function.
Nor is mine. Could you create a one-to-one function for this problem?
No, you can't.
Go to questions.
I have a question on a symbol that they use.
Okay.
It was used a lot in like definitions for chapter 0, but you see it in number 14. It looks like the euro symbol. It has like a C with a line through it.
Yes.
And it looks like an E as well.
It's kind of supposed to look like me.
Get that one.
That stands for element of,
Element of.
or as in a set, or as the book says, I think it uses the word member of.
Number of.
Member of or element of, what it stands for. So it's indicating the object that precedes the symbol to the left of the symbol is a member of the set that comes after the symbol.
Okay.
Covered here. Anybody get past the first page on the whole? Did you get so bogged down on the first page?
Are we supposed to do all of it?
Yeah.
I did all of it.
I did all of it.
I did all of it.
So the first page is the hard part though.
Uh-huh.
We didn't really have questions on the rest of it where you have to apply your skills to the problem rather than have to create your own or that's good. That's good.
I have a question. Okay, so in like 57 through 62, I think it was, it asked like you to locate all the different parts of the graph, and one of them was inflection points. And when you go to look at the definition of it on page 6, it just says that we'll go over it in section 3.3, and it doesn't say what it is.
That's true. That's a little bit sketchy in my mind too, that they would not give you a definition that asks you about it. They do describe it. They don't give you a formal definition. So it says the graph changes concavity.
Yeah.
That's what an inflection point is. So what do we mean by concavity? Well, right above it, it says concave up. Once again, they don't define it for you, so it's sketchy, but it says that the graph curves upward. So a concave up part of the graph is going to have a cup that the whole liquid, say, in it, and concave down part of the graph would be with curvature opening downward. Okay, so when you have change from cupping up to cupping down, so like that, you have an inflection point. Your graph is flexing from going one direction to going the other. That makes sense.
Yes.
So I have a follow-up question. I have a follow-up question on that. If graph doesn't change concavity, would we just put there is no inflection point?
Correct. Yes.
Okay.
For example, on 57.
Well, we need to.
Go ahead.
No.
Ask me that.
Okay, well, we need to know what an inflection point is for the rest of chapter 0. Or will it come into relevance again at chapter 3 and I
It will
can
become more important later. Now they're kind of introducing it, so you just, in pre-calculus algebra, graph functions. You may have probably talked about local maximum and global maximums and stuff. We'll go further and get into where an inflection point is in more detail. So for now, it's just, can you spot where it changes from curving up to curving down? That's why you get to.
I mean, isn't that just a maximum or a minimum though?
No.
Get it.
So like in
Let's
question.
look at a couple of them. Let's look at 57. Look at picture 57. 57, does everyone see a local minimum there?
Yes.
Good. Does everyone see a global minimum there?
Yeah. Sure.
Well, what about a local maximum?
No.
Oh, what about a global maximum?
No.
Oh. Now, what about concavity? If you start on the left side of the graph, to your left, the graph kind of seems to come down, and as it's doing that, the inside of the curve, imagine trying to drive through a curve on the road. The inside of the curve, you can feel that inside of the curve. Well, as you come down that graph, it's curving this way the entire time. So which way is the inside of the curve on that graph the whole time? Up. So we'd say that entire curve is concave up. So there's no inflection on it because it didn't change from curving up to curving down. Okay. Well, let's look at number 58. Where's the global maximum on 58?
3.
1, 3.
Good question. There isn't one. Look at the right-hand end of the graph. What does that end indicate? There's not a dead point there. That means the graph continues in this pattern. So it would not have a global maximum. Does it have a local maximum?
Yes.
Yes. What is, when we talk about local maximums or minimums, we generally identify the location. So where is it located? What x-side? What is the local maximum? That's the value of y. So when we ask about it, we generally identify the location. So there is a local maximum at 1. What about what's occurring at x equals 3? Did you identify that?
So local minimum.
Local minimum. Is it a global minimum?
No, we don't know.
Now, because I don't think so, but they're not real clear on that graph. But generally, if the graph ends, they put a solid dot there. Otherwise, it's interpreted to go on. Now, what about concavity? From x equals 0 to x equals 2, what can you say about the graph?
Concave down.
Concave up.
Going through a maximum, local maximum, and continuing down. But then at x equals 2 to x equals 4, what can you see happen? Kind of goes through a local minimum. So we've changed from concave down to concave up, and that change where it flexed. It's called an inflection. So at x equals 2 is an inflection. Does that make more sense now?
Yes.
Yes.
What would you say about 62?
62.
Okay, so everyone take a look at 62. Let's take a poll. Everyone has to vote. It's an A-B choice. Your choices are inflection point at x equals 0 or no inflection point. So all in favor of inflection point at x equals 0, raise your hand.
I don't know, man. I'll go with it.
0, 1, 2, 3, 4, 5, 6. How about no inflection point? Raise your hand.
Got him.
Okay, we got 4 here, and it looks like 4 or 5 there. So the x equals 0, no inflection point outvoted the others, and that's good because that's true. Why is it that there's no inflection point? Like there's a minimum there, and I agree there's even a global minimum, but no change in the curvature. To the left of x equals 0, it's curving down. And then at x equals 0, when the graph starts back up, it's still curving down. You see that? So there is no change in concavity, so it's not an inflection. That point is actually has a special name called a cusp. We'll get back more back. Cusp. C-U-S-P. Cusp. 5 minutes. Okay. Well, again, I've been given a 5-minute warning. Any last questions in section 0.1?
I have a question. On the same part, it says intervals in which the function is positive or negative. How would you describe that or write that down?
Okay, so for example, tell you what, we'll do one. How about number 6? We'll only have to answer domain and range. So number 60. Everyone's got domain and range, no problem? What's the domain of number 60? How should I write that? The question is, how do I write this stuff out? You're right. How do I write this out? I have a test. I got to write this stuff out. It appears the domain to me is negative infinity to positive infinity. I agree with that. What about the range? Someone else besides Joe.
Bracket -3
Negative.
to positive or to infinity.
I'm sorry. Who was that? The DCC who said that? Emily? No, you were Kyle. Okay, Kyle. Good. Yes, I agree. Location of roots. So how do you identify that?
Where it crosses the x-axis.
Okay,
Right?
so
X equals negative.
And x equals 3.
and you have to identify intercepts.
Y equals negative.
I guess they need the y-intercept there.
Yeah. Y equals negative 1.
Good, I heard that. Local and global max and min.
Do you have a global minimum on it?
Where's it located?
2, -3. Isn't that globe min though?
Referring to the point.
Oh, you're right. Global min. Thank you. Good catch.
This isn't gonna go back.
Is there a local minimum?
Same thing.
How about a global max?
None. None? NA. Not available.
Local max?
No.
No.
Inflection points. What about inflection points?
I think there is.
No, because the concavity doesn't change.
Yeah.
It does. It changes from -1 to -3. From x equals 0 to x equals 2.
Yeah, but it doesn't like go up or anything.
No, it's still concave down, isn't it?
Yeah.
X equals 0, X equals
This
2.
way.
Hang on a second.
It just looks like an oblong.
I don't know, man. I don't know.
We all agree that certainly that's an inflection point there because it's concave up, then it's concave down this way. We all see that?
We can't see.
Move it over to the left.
Oh.
Don't zoom out. Zoom out.
Keep on going. Yeah.
Too
that's
much.
it. Too much. Too much. There you
On the X
Yeah.
right there, you all agree that that's a inflection point. Agree?
Sure.
Yes.
I'll take it.
That X equals 0. Do you see another one?
Is the minimum one?
X equals
No.
2.
I'm going to agree with Joe. X equals 1.
Wait,
It is X equals 1.
What happens at X equals 2? At X equals 2, okay, so there's 2. At X equals 2, you're going through a minimum, so you're curving up the whole time. But you're curving down here, and to start curving back up somewhere in here, you had to change. Back up.
Got it.
Real quick, I don't have time. I got to finish the answer. I had to write up this answer. Okay. Which positive increase and decrease is okay. Function is positive. Where's it positive? Positive is above the axis, right? So where's it above the axis?
From negative infinity to negative 1.
Else is it positive?
And from 3 to infinity.
Good. Notice I did not include the endpoints. Why is it not included in the endpoints not included in those intervals?
Because 0 is neither negative or positive.
Answer, who said this? That's 3, is that right? Yeah. Good. Yes, the 0 is neither positive nor negative. Good. What about where is it negative? Okay, well, if that's where it's positive and the domain is all of everything, then I can tell you where it's negative by just looking at this, right? So where's it negative?
Where it's not positive. Oh, that's real good, Chloe.
No, be careful. It's negative's not the opposite of positive. Because again, 0 is neither 0 is neither positive nor negative. You said not where it's not positive, you have to include the endpoints.
Mm-hmm.
Okay, so increasing or decreasing? Where is it increasing?
Negative 3 to infinity. Use X, so 2 to infinity.
Would it be from 0 to 5 to
Yeah. Is it 2 to infinity? Yeah. You wrote it down.
Where's it decreasing?
Negative infinity to 2.
Good. Concave up or down? Same idea. I think we got it now. Concave up. Where's it concave up? Well, we talked about it here.
It's around the 0 zone.
Infinity to 0 and 1 to infinity. Where is it down? Well, everywhere it's not up. So that's got to be from 0 to 1.
Got him.
Where's all the vertical asymptotes?
There is.
Ask-
There are some. There are some.
Are there? I don't see any. Okay, we're out of time. Thank you for your time. For tonight's homework, go ahead and work on section 0.2. Read it. Open homework. It's located on Moodle. Tomorrow, double check, make sure there's a full attempt of the homework on 0.1.
So it's basically a flipped classroom.
Oh.
And right before-
Okay, well.
That around. So, everyone needs.
But I had to reprint the first page. And I thought I had an extra copy of this.
Wait, I have a question first.
Right. I'll decide, I might decide.
I'll get you a copy of the odd.
Well, no, I'm supposed to, I'm gonna go try to get my book back and give it to my accounting class.
Well,
Okay. All right. And, okay.
oh, I got another
I'm confused.
Yeah, I got the.
I could probably do it. So it's a function that maps real numbers. So when it's asking me, blah, blah, blah,
I was trying to do, but I like.
function, like a function A, so it would be like x equals 1. So A would be like x minus 1. So I should say that this is step.
I had to work last night and then
It's just like a live, yeah.
and then work on the math.
A constant function is a function where it maps the there's some D
Like, what is this thing?
There's some D that is an element of that function.
I had to learn my test.
Function equals.
It's hard to see that.
I was up early this morning.
So for example, like if your function was contained in x equals 1, right, then it would just be all
Oh,
numbers.
yeah.
Stay up until.
I
space.
always
And B
think
could
that's a
be
good
the number
idea,
3.
and then it's never a good idea.
And B would be an element of x minus 1.
Yeah.
You see what I'm saying?
Yeah, so what is this one saying?
A constant function, so wait, hold on. Describe, so you're trying to come up with a constant function that maps all real numbers to all real numbers. And then here, you're trying to come up with a constant function that just maps the real numbers to -5 to -2.
So this is the domain.
Yes.
Nice.
So you start at -5 and you end. Yeah. Yeah.
So are you just looking for a formula, or are you looking
Yeah, you're looking for, are those magic genes? Okay, because just an example, because there's a lot of them. For this one over here, I'm 15, like when I went to that,
Awesome, I needed mine.
for 15.
Is it a good day?
It's the same thing, it's just different. Well, it asks if it's well defined or not. So if it's asking if it's an identity function where A goes to A, which means that there's no change, right? And what it's saying that no matter what you put in, you're always going to get that out. So the first two would be yes, and the second one would be no, right?
That'd be my guess.
Well, this is a lot different from this, because this is saying, is it the identity function? Where down here, you're actually trying to describe a function.
Like if you
You see what I'm saying?
Is he ever gonna I've never been in his class before. I have no idea.
No, but we do.
Because if he expects me to read this book and fully understand and comprehend myself,
I have never, ever sat in his class, so
Have you ever said to him before this class?
yes, I have, yes. And he's
you
really
should
cool.
suggest that he wears a microphone.
Oh, is that
Like
a
on
thing?
his shirt. Oh my god, you're all.
Can you do that?
Where would you find this?
Yeah. Or just carry around with those things and constantly talking.
So, Bree, on that first one, think of something like a horizontal line, where it can be all real numbers. So it's just a line. It could be any line. It could be like f equals 1.
Yeah. I didn't think a horizontal line was a function though.
A horizontal is what a vertical line is.
Yeah, it's just not 1-to-1.
Okay.
It's a function, it's just not a 1-to-1 function, yeah. And then in the second one, it would be a horizontal line that just goes from -5 to -2.
Doesn't it just say argue with function?
So it would be f of 1 only defined in that domain.
So you would write it where it's all values of x, and then you put the domain.
Yeah. So like in the first one, it would be f of x equals 12
Did you do all of them?
in the set of all real numbers.
I don't
And you
understand.
think that all the numbers
I don't understand the concave points.
I understand that
Stuff like
stuff.
that. Like,
Just the turning, it's just where it turns. If it doesn't turn, then there's no contact. There, wait, hold on. You don't understand the inflection points?
inflection points.
Okay, it's just where it turns. If it never turns, then it doesn't have it.
Like if it turns, but like on a parabola, it goes like that, but there's no inflection
It never
point.
turns.
So like,
Always up, it's always concave up.
so, but if